In this video we're going to talk about how to find second derivatives. And in order to find the second derivative, we need to first find the first derivative. So the process is going to be take the first derivative, and in some cases we may need to simplify or rewrite, and then we'll take the second derivative. And we're going to simplify and rewrite to make the second derivative as easy as possible. In this first example we have a polynomial. So the first derivative, f prime of x, is going to be equal to 3x squared plus 6. Now in order to find the second derivative of this function, we just need to go ahead and use the power rule again. Because we only used the power rule, we didn't need to rewrite or simplify, so our second derivative becomes 6x. So this is our most basic case. Here in this next example, we have the quotient rule. And oftentimes with the quotient rule, we're going to need to simplify it so that we can use the quotient rule again without having to combine it with the product rule or some of the other rules. So here our first derivative, f prime of x, is equal to the denominator, 3x squared plus 1, times the derivative of the numerator, which is equal to 5, minus the numerator, times the derivative of the denominator, which is 6x, divided by the denominator squared, 3x squared plus 1 squared. Now if we were to leave it in this form and take the second derivative, we would have a couple different places where we'd have to use more rules. So what I like to do is to go ahead and simplify the numerator to make the second derivative easier. So what I'm going to do is multiply the 5 through both of these terms, giving me 15x squared plus 5, minus, now I have 5x times 6x giving me 30x squared, all divided by 3x squared plus 1 squared. And then I'm going to simplify this one more time. I'm going to combine my x squared terms. So f prime of x is equal to 5 minus 15x squared divided by 3x squared plus 1 squared. And we're going to use this now to take our second derivative. So we got it in the simplest form possible. And now f double prime of x, again, is the quotient rule. And then we're going to need to use the chain rule when we take the derivative of the denominator. So here, 3x squared plus 1 squared is our denominator, times the derivative of the numerator, which is negative 30x, minus the numerator, 5 minus 15x squared, times the derivative of the denominator, which is the chain rule. So we multiply the two down, rewrite what's inside the parentheses, subtract 1 from the exponent, so it's raised to the first power, and now times the derivative of the inside, which is 6x, all divided by 3x squared plus 1 squared, and then squared again. And in this next example I wanted to show is using the chain rule for the first derivative. And you'll see that by using the chain rule, the second derivative turns into the product rule. So here we have f prime of x is equal to 2x cubed plus 3 times 3x squared. And what I'm going to do is combine the 2 and the 3x squared, and I'm going to rewrite this as 6x squared times x cubed plus 3. And now I'm going to use the product rule to take the second derivative. So I have 6x squared times the derivative of x cubed plus 3, which is 3x squared, plus the derivative of the first term, which is 12x, times x cubed plus 3. And in this example, we see that the second derivative doesn't always follow the same rule as the first derivative. So you can take the derivative of a function and have it turn into a different derivative rule to take the second derivative. So you have to be careful